Now for some tips to solve limits that may not immediately look easy to solve. So first, if the function is a quotient type, so in other words it's something divided by something else, you can try factoring and canceling. Number two, if the function is a quotient type and the numerator is some funky looking thing like a square root or multiple fractions, you can try rationalizing it. And third, if all else fails, go for the squeeze theorem, which will be shown in the video for tomorrow. Alright, so first let's take an example of just a simple quotient type problem. So we have the limit as x goes to 0 of negative 2x squared plus x over x. And this is going to equal some limit value L. So if I plug in 0, I'll get 0 over 0, which can't happen. So the first thing I'm going to do is factor out 1x out of the numerator and see if I can get that to cancel with the denominator. So since it does cancel, I am left with limit as x goes to 0 of negative 2x plus 1 equals my limit value, which in this case is just 1 because I can plug in 0 for x. Okay, so how about another example for factoring? So the limit as x goes to 1 of x cubed minus x over x minus 1, and the idea here is the same, to see if I can factor the numerator so that the one factor of the numerator will cancel the denominator. So in order to factor this, I'm going to use synthetic division, just to give you a reminder on how it works. So I use my 1. You have to multiply and add going down as you're going across. We can review this in class if you wish. And I get that my remaining function after I've factored out x minus 1 will be x squared plus x. Put that back into my original limit. And check if they cancel. They do cancel because they're both factors. And that means I can go back and just plug in x equals 1 as my limit value, as my function value, because this will be continuous. And I get the total limit is equal to 2. Now going back to the synthetic division that's in the top right corner, you put the x value in that little backwards L shape. You don't put the negative one, you put the positive one, because at the 0, x will be equal to 1. So that's why I'm using a positive 1 instead of a negative 1. The 1 is from the coefficient from the x cubed. The 0 is because there is no x squared in the original one that I'm dividing. The negative 1 is from the negative x, and the 0 is because there's no constant term. I drop down the first coefficient here, and then I multiply going back up. I add going down, and then I just repeat going across. When I get to the end, if my final answer right here is 0, then that means I have a good factor. Okay, now to practice rationalizing. This uses the idea of a difference of two squares in order to get rid of square roots or fractions or anything else we might want to cancel out. So since I have the square root of x plus 2 minus the square root of 2, I'm going to see if I can multiply this quotient type by the conjugate of that, which means plus instead of minus. So I have x plus 2, or the square root of x plus 2, plus the square root of 2. And I'm going to multiply this on the top and bottom as a new factor. Now what this should do, if it works right, is it will allow the x plus 2 square root to become x plus 2 minus 2. And then I'm going to keep my factors separated out on the bottom. Now there's a reason for this. Remember, I'm trying to cancel things out so I can get rid of that 0. And so I need to keep them separate for the time being. The 2 minus 2 will cancel each other out, and then that leaves me with an x over x, which I can also cancel out. And that leaves me with a tidy little 1 over square root of x plus 2 plus the square root of 2. Which, after I plug in 0 for x, I can end up with a 1 over 2 square root of 2, which I then need to rearrange into square root 2 over 4. The reason I need to rearrange it is because having a square root in the denominator of a fraction is considered improper. And I can show you exactly how I did that tomorrow. One more example, also of rationalizing. So this is the limit as x goes to 3 of the square root of x plus 1 minus 2. And this is divided by x minus 3. Same idea applies. I'm going to see if I can multiply by the conjugate and get that x minus 3 to cancel out. Okay, this is using the difference of two squares. If you need to, we can go back over difference of two squares tomorrow in class. And this should leave me with x plus 1 minus 4 in the numerator, and then my two different factors in the denominator. Notice I'm still keeping my factors separate because the goal of the whole thing is to be able to cancel out some factor. I get x minus 3 on the top, and this will cancel out nicely with the x minus 3 on bottom. I forgot to put parentheses, so I went ahead and did that. And this leaves me with the limit as x goes to 3 of 1 over the square root of x plus 1 plus 2. Plug in my 3, and I'll end up getting 1 over 2 plus 2, which is 1/4. Now, something else I want to draw attention to is that each time that I rewrote my limit, I always wrote the notation at the beginning until I actually took the limit. That's the only step where I did not write limit as x goes to 3. This is important notation, especially for the AP test. If you don't write that limit, then they are going to assume that you have already done the math for the limit and you are now writing the answer. Alright, that's it. See y'all tomorrow in class. Make sure you go back over your notes on how to factor and cancel to find easier limits, and how to rationalize also to find easier limits. Later.